The school once attended by now famous Dr. Frohlich. Yeshiva University and Yeshiva High School alumnus Dr. Frohlich has had an unprecedented medical breakthrough. Less than 20 years after graduating this very high school, Frohlich discovered how to program human cells to create a so-called personalized model for medicine. The scientific community is ecstatic. Stay tuned for Dr. Frohlich's TED Talk on her accomplishment, its significance, and what she envisions for the future.
I'm here to talk to you today about the future of medicine. But to do so, let me first talk about the past. Medicine for the past 100 years or so has been dictated by Alexander Fleming's discovery of penicillin, leading to an age of antibiotics and vaccines. An age which, undoubtedly, has been successful in essentially ridding the world of deadly diseases like polio, diphtheria, and smallpox. This essential discovery has left lasting effects on the human race. Raising life expectancy and saving lives are just the obvious ones. But it also defined the very path and practice of medicine. We set out to identify a single disease and then found a single complementary and universal cure for it in the form of a vaccination and antibiotics. We identified polio, and then we created a vaccine. Yet we now face a different kind of disease. And as much as we are trying to find a single cure for this disease, our efforts are to no avail. I'm sure you have figured out by now that I'm talking to you about cancer. When I was a little kid and I told adults that I wanted to be a doctor when I grew up, their response was almost automatic. 9 times out of 10, they'd say back to me, "So, you're gonna find the cure for cancer?" But you see, the idea of the single cure is misleading. Cancer isn't this lock that has one key. It varies from person to person and changes as time goes on. To conquer it, we must shift gears, from a general perspective to a personalized one. Essentially, we must change the focus of medicine. For this new personalized approach to medicine, the single cure is no longer applicable. We will conquer cancer in a personal way, by programming a patient's own stem cells. Why not take a patient's stem cells, tap into its DNA sequence, and identify the part of the sequence that needs to be changed, so that we can create a specialized cell that can complete any task that we program it to complete. You might have noticed that I used the word can in the past few sentences, and if this was 20 years ago, I would have been correct to do so. But it is now 20 years later, the year 2035. We no longer can, but we have programmed such stem cells. Biologists have worked with nanotechnologists to tap into the human genome and program a cell that can carry out any function in a perfect display of the synthesis of technology and biology. We call this new field CPRO, a field geared towards programming cells to fit the personal needs of each patient. The applications are endless, but I'll mention 3 areas that are being revolutionized by CPRO. 1, immunology. Programming a patient's cells to fight a particular cancer. But unlike a generalized approach, these stem cells will be the patient's own cells, so they won't be rejected by the body. If an immune system is damaged, like from HIV, we can program stem cells to reintroduce the immunity back into the body by programming T cells and B cells. 2, tissue regeneration. We can program stem cells to generate tissue to repair damaged organs or to even create completely new organs. It's like 3D printing, but for the body. In our world where an increased population leads to organ donor shortages, the regeneration of organs within the lab is vital and even preferable, as these organs made from the patient's own stem cells won't be rejected by the body. 3, molecular breakdown. Programming cells to break down unwanted particles. These particles will vary from patient to patient depending on the disease that they have. For patients at risk of coronary heart disease, their programmed stem cells can break down cholesterol. For those with diseases that lead to an accumulation of adipose tissue, like Tay-Sachs, stem cells can be programmed to target fat cells in a particular area of the body. The cool part is, we can also use these stem cells as body sculptors, and they can take the place of the liposuction industry as they can be focused to break down fat in highly specified areas. As I said, the applications are endless, but a century's worth of scientific study have taught us passing through one doorway leads to hundreds more. We are now on a new, redefined path of medicine, but our job is to continue to pave the way with more research, more study, more innovation. In an age where each patient has a slew of specific needs, their treatment should be specific, and CPRO is just the start. Thank you.